So today we are doing Airflow and Flix. Airflow basically is a workflow automation platform used to schedule tasks, used to organize and run data tasks. So let me try to explain it better. So do anybody know anything about ETL? Like, have you heard of anything like ETL pipeline before? Come across it? Like ETL.
ETL,
Okay.
export, transform, and load.
Extract, transform, and
Extract,
load.
transform, and load.
Yeah. That's good. That's good. Yeah. So as a data engineer, basically, one of the major things we do is build pipelines. And one of the pipelines we build is ETL pipeline. Sometimes it might be ELT, which is extraction, transform, and load. And ELT is like extraction, load, and transform. It's just like bringing one process before the other. So building a pipeline, ETL pipeline, the extraction, like extracting data from different sources. We have different kind of sources. We have extracting data from APIs. We can extract data from maybe a CSV files and so on. Sometimes in an organization, we can extract data from CRM, which is customer relation management. So there are many sources where data can be extracted. So transformation means transforming data, making your data clean. Extracting data, they can come from where they are coming from. There will be a kind of anomaly in the data. What I mean by anomaly is like different kind of maybe duplicate value. To make it more simpler, the data will be dirty in short. So after extraction, to transform, you are cleaning the data. You are making the data clean. You can't work with dirty data because when you work with unclean data, definitely anything you are doing with the data, it will actually bring the best out of the data. So the transformation includes cleaning, like removing the duplicate values from the data, removing the non-values, and so on. That's transforming. And loading, which is loading into our database. It might be relational database and it might be different kind of database. We have relation like Postgres database, we have MySQL database, and we have non-relational database like MongoDB and co. So that is loading. So to automate these whole processes, like to orchestrate. Orchestration means to make this, every time when this pipeline is built, we can't just be going there and be doing our orchestration ourselves. We have to automate it, like we have to make it this thing should run itself. Do you understand that? And we have to schedule, like, maybe the data, maybe from our source, the data must be extracted maybe every morning. So when data is extracted every morning, this pipeline has to be flowing. So what makes this pipeline automated, like the automation, like making it flow automatically, is
lab section.
Airflow.
This lab is about Airflow and Apache Flink. You guys have to study the theoretical portion of Airflow, why we need Airflow, what it is used for, generally for the ETL process. And we'll also be discussing about Apache Flink. The Flink is generally most about streaming data, right? So yeah, let's dive into this. Okay. So this particular lab is divided into three different small labs. Two of them are for Apache, two of them are for Airflow, and one single lab is for Apache Flink. And we'll be demonstrating how to create those in real life, how to create different DAGs, how to implement the Python code within the Airflow, and how to host those things internally for now. And I will be guiding you a little bit about how to do that in the production environment as well. So I believe I don't have to explain the details about definition and work and why it is used, what that is, the tool itself. You guys have already learned about that. But in this lab, we are going to focus on how to run and install and implement those things. Okay, so first and foremost, we need some installation being done in our system. So this is my laptop, and we have to install something called Docker. So there are multiple ways to install, Airflow or Apache or any other tools in your server or in your application. The most common one is Docker, right? Because with Docker, you containerize the stuff, and it is the most, microservice architecture. You can use it in production environment. Most people obviously use this as a primary go, but you can also install all of these tools by command line. Without Docker, you have to run different commands and set up different configuration file, and it works as well, right? But the Docker is most easiest and faster to do it. And generally, when you work in the companies, you're probably working with Docker itself. So I'm not going to go through how to install Docker and stuff, because it's going to take a lot of time to download and install all of these things. Okay, we got Docker, we got Java, etc. Right? So all of these things has already been installed in my system. So I'll just go through how to install this documentation, and we will dive directly into the lab section, right? So first and foremost, Docker installation, you just go to this Docker Dexter website, and you can download the installer, right? For Windows. You can just download this Docker. And depending upon your system, maybe you are using Linux like me, or you are using Windows with different chipset, Mac OS with different chipsets. So whatever your system is, just click on it, download it. And once you download that, if you type Docker desktop, so you will have something like this open up. Okay, so I'll just delete the thing that I already have in, and just give it some time. Okay, you will have something like this, right? So this is the Docker desktop, and it enables you to have a Docker client and Docker server all together in one place. So you don't have to install both of these. So with this, you can just start working with Docker itself.
So Snowflake is a cloud data warehousing and scalable analytics solution. It is a very popular tool when it comes to data engineering workflows, and even some AI workflows, specifically machine learning, because it usually involves quite a lot of data processing and data cleaning and such. All right. So to start, I guess, we should kind of define what is a data warehouse and what is cloud data warehousing. So a cloud data warehouse is a fully managed analytics environment hosted in the cloud. It provides flexible compute and storage, high-speed analytics, and pay-as-you-go efficiency while remaining easy to integrate with other cloud services. So as you can see below here, it integrates with quite a lot of different services. So it can integrate with other data warehouses and databases, like I mentioned before, machine learning workflows, data science use cases. So data science obviously deals with a lot of data and analyzing that data and processing that data, stream processing. So in the case where you have quite a lot of real-time data coming in, it could also accommodate stream processing and data preparation for data lake. Right. So I think as we move on, we'll see the differences between what a database is, a data warehouse, and a data lake, right? Because they each have specific use cases and they have specific definitions. Right. So to start off, just a quick question for you guys. So stream processing, right? So I mentioned real-time data, and it's more about managing and handling that real-time data and processing it. Can someone give me an example of what would be real-time data, just in the everyday world? What would be considered real-time data? What would produce real-time data? Can anyone give me an example? Lots of examples.
Say streaming data.
Okay, but can it be more specific? Streaming data. So that you are correct in saying that, but can it be more specific in what data you'll be streaming? What is it, like a platform or something like that?
Okay, let me let's say real-time data. I could use example. Let me say sports scores.
Okay. Yeah. So sports scores, right? That's a really good example. Wasn't one I was thinking about, but that is absolutely a really good example. Also, streaming events like sports, for instance, leaning into what you're saying, that is another example. That's a really good answer. And a really good one, which is very prevalent throughout the industry, is IoT devices, right? So IoT stands for Internet of Things, and basically it's like small devices that collect data, and usually this data is sent somewhere to be processed and or stored. Um, right. So you have things like sensors. For instance, a good example of an IoT device is for those who live in London or even just across the UK. Um, you take transport, right? So you take trains, you take buses, right? But you can usually go onto apps, whether it be Google Maps or City Mapper, and you can see, okay, well, this bus is now at this location and it'll be here in 15 minutes, right? So this bus has an IoT device on it and usually is connected to a network, and it constantly updates the network with that streaming data or that stream processing that we're speaking about here. And that is how the applications like, Google Maps or whatever you're using on the internet, is able to see this data, update it constantly, give you constant updates and keep you informed, right? So that data from the IoT device and the bus is streamed to your device, right? And it's streamed through a lot of the data infrastructure that we're seeing here, warehousing, things like Kafka plays a big part as we see later on. And yeah, so that is, another good example of stream processing or streaming data, right? So we'll see a bit more about that later. Yeah,
So
and
Module 1, PySpark and Kafka, or generally known as Apache Kafka, Confluent Kafka. Okay, so both of these are open source tools. So you don't really need to pay to buy a software license. Okay, so these are open source tools by Apache. So Apache is a company that creates this. I wouldn't say a company, but it is an organization. People get together and build an organization and produce a free licensing software, right? So diving into PySpark, let's talk a little bit about big data. What is big data? Why it is important in today's world, and how does PySpark play a role in big data industry? So let me just start drawing stuff over here so that it will be easy to explain you guys. So big data is any data, computation, or process that involves huge amount of data. Okay, huge data size. So how huge are we talking about? So we are talking about the size that our normal computer or a single server cannot handle it. Okay, so we are talking about more than like hundreds of GB of data, right? And it can span up to like terabytes or even petabytes. So generally, when we discuss about database technologies, storing data and other stuff, if we are with a small organization building a small application, then we'll be more focused on databases, right? Like MySQL, it could be like Postgres, or somewhere around like storage technologies. Now we're going to talk about Kafka. I did explain a little bit about this. What is Kafka? So it is a streaming service. So streaming is something that we collect the data continuously. For example, when we go to Amazon site, right? So we do a lot of things. We click on some product, we click on add to cart, we click on maybe like processing or like buy stuff. So all of these are also datas, right? Whenever the person click on certain product or items for the company, it is the data, right? Then these data are also streams. We call it click streams, right? So what does a click stream use for? It is used to analyze the behavior of a person who is trying to buy stuff. So it will understand like when the people click over here, the person click on this product and then it clicks on that product. So maybe these two products are linked somehow. Maybe some people who buys this product also like this product, right? So it is a clickstream analysis. So let's say from the next time, whenever some person click on this product again, the next person, then the system will automatically recommend the second product to that. So maybe they can make a better sale on this, right? So this is one example of streaming service. And with the help of Apache Kafka, you can capture those and then stream it to our Apache Spark.